How is this problem different than the ones we talked about yesterday? Has three variables. If it has three variables, what's the minimum number of equations that we need in order to solve it? 3. Can we have more? Yes, but we need at least 3. Okay? So we've got to figure out what to do here. All right? And today I want you to know we're going to solve this by substitution. I'm sorry I put a dot over the U. I don't know what I was thinking. Okay, we're going to solve this system with substitution today. Well, you already knew that because you already copied it down, right, from the lesson plans, okay? But just to have it in the notes on the video, okay? So think back to yesterday when we were solving linear systems by substitution. What did we do first? We did. That's exactly what we did. We got a variable by itself, okay? Now, look at these variables that are right here. Which one do you think we ought to try to get by itself? First of all, could I choose any of them? Yes. Yeah, I could choose any of them, okay? Is there some that are better choices? Yes, because it takes less work to get to those, okay? The ones that are better choices are ones that don't have a multiplier or they're very low multipliers. Is there one that are very low or don't have a multiplier? Well, this x, this y, and this z, neither one of them have a multiplier, right? But what's true about these two? They're negative, right? They're negative. So if we have a choice between a negative and a positive, the positive is going to be easier. So let's choose to isolate this x right here, okay? Now, remember, you could choose any variable here. We're going to choose this x only because it's a little bit easier, okay? Excuse me. So if we have this x, how do we isolate it? Yeah, move the y and move the 4z, right? So x equals 10 plus y minus 4z. Now the whole purpose of substitution is that we substitute it, right? So now that I've solved for a variable, I would like to substitute it into another equation. Which other equation should I choose? The bottom one. Why would I choose the bottom one? It's the only one with an x. We can't choose this one because I just used it to solve for x. Plugging it back into there won't do me any good, will it? Okay? So if I'm going to choose the bottom one, that means anywhere there's an x, like right here, I'm going to put this in for x. So I'm going to say 2 times x, which I know is 10 plus y minus 4z. And then I have the rest of the equation, right? I just wrote 2x so far. So I have 2y, and I have minus z, and equals 12. Just make sure you don't forget the rest of that part, okay? Now what do I do from here? Distribute. Here, here, and here, right? To all three of the things in the parentheses. So I have 20 plus 2y minus 8z plus 2y minus z equals 12. Okay so far? Well, notice here and here, those are both y's, aren't they? And notice here and here, those are both z's, aren't they? So I should combine like terms, shouldn't I? At the same time, could I subtract 20 from both sides? You okay with that? I mean, gosh, guys, that's 3 steps all at one time. Are you all right? Okay. So if I combine my y's, I get 4y. If I combine my z's, I get minus 9z. And when I subtract 20 from both sides, I get negative 8. So here's what I need you to notice. I have an equation with y and z. If I have one equation with y and z, what do I need? I need another equation with y and z. Oh my goodness. I have one, right? Well, since we're solving by substitution, I need to solve for a variable. So just looking at these two equations that I just put the yellow star by, this is my new system. Should I rewrite that separately? Would that help a little bit? Okay, I'm going to go ahead and rewrite that down here a little bit. 3y minus 6z equals negative 6. Now all I did was rewrite that equation right here. I'm just giving myself a little bit more space to work. And then 4y minus 9z equals negative 8. And that's just the second equation right here. Okay? Well, guys, this is just what we did yesterday, isn't it? Okay? So I want it, but I'm still solving by substitution, right? My directions are to solve by substitution. So which variables should I choose to isolate this time? Are there any that are by themselves? Okay, so then we need to start making some wise choices here. Okay? If I solve for this y, I'm going to subtract 6z from both sides and then have to divide everything by 3. Is that going to be okay? Yes. If I try to solve for this z right here, I need to move the 3y over here and then I have to divide everything by 6. What's that going to do in this term? It's going to make it a fraction, isn't it? So would I rather have fractions or not? Okay, so then I don't want to probably solve for this z. If I try to solve for this y right here, I would have to add 9z to both sides and divide everything by 4. Well, that's not a problem here, but fraction there, isn't it? If I try to solve for this z, I'd have to move this 4y to this side and then divide everything by 9. Ooh, fractions on both of them, right? So which one should we choose to solve for? The 3y, right? So I'm going to choose to solve for that variable right there. Not the 3y, just the y. Okay? So if I solve for that, how am I going to solve for that? So add 6z to both sides. So 3y equals 6z minus 6. And then divide everything by 3. Y equals what? Try one more time. 2z minus 2. Everybody okay with that so far? Okay. Now that I know what y is, what should I do with it? Where? Where should I plug it in? To the other equation, right? That I just have in my system. So I'm going to go right here, right there. So I'm going to write 4 times y, which I know is 2z minus 2 minus 9z equals negative 8. Same thing as I was doing before, distribute here and here. 8z minus 8 minus 9z equals negative 8. If I combine my like terms, I get negative z minus 8 equals negative 8. And if I add 8 to both sides, negative z equals 0. So what does z equal? 0. So now that I have one of my values right here, what should I do with it? Where should I plug it in? Which one? Guys, how about this one? Wouldn't that be nice? Wouldn't it give me what y equals? Okay, so if I take z and plug it in right up there, I get y equals 2 times 0 minus 2. Well, 2 times 0 is 0. What's y? Negative 2. Where should I plug that one in? So all the way back up here at the beginning? Do I need to stop? Are you okay? Okay. So now I want to take both of these and go up here to the top. X equals 10 plus y, which is negative 2, minus 4 times 0. Well, again, what's 4 times 0? 0. What's 10 plus a negative 2? 8. Mm-hmm. So now I have to figure out if I'm done. I need to check it for sure, right? Okay, so check it for sure. So this is where we go back to the very beginning, right? Okay, 3 times negative 2 is negative 6. 6 times 0 is 0, so negative 6 equals negative 6. Okay, so it's right? It works. So that's it. Why would I have to plug it into every single equation? Exactly. It might work for one and not all of them. We have to make sure it works for all of them. That's how we know it's the solution, is if it works for all 3 of them. Okay? So I know it works for the first one. We're good on the first one. Okay? What about the second one? Well, x is 8. 8 minus a negative 2 is 10, right? And then 10 plus 0 equals 10. Does that work? Okay. 2 times 8, 16. 2 times negative 2, so 16 minus 4 minus 0. Does that work? So is this the answer? Is it? Did it work for all 3 equations? So it's the answer, right? So the last thing we have to figure out is how to write the answer. Do I just square all the things like this? Well, here's the thing. Think back to yesterday, okay? When we talked about a system of linear equations, how did I write my answer? As a point, right? It was a point because we said it's 2 lines, it's where 2 lines cross, and where they meet is the point of intersection, and that's the solution, right? How are we going to write our answer today? Well, I agree with that. Okay, I think that's correct. I think we should write it XYZ, but I need you to understand that it's a point. It is a 3-dimensional graph. That's exactly right. Okay, the first one, this is a line, isn't it? XYZ, that's a line. Do you know what this one is when you graph it? It's a plane. And this one is what? A plane. So I have a plane and a plane and a line. Okay, here's 2 planes and a line. Let me zoom out just a little bit so everybody can see this a little bit better. And there's my hot chocolate. See my hot chocolate? Okay. I said hot chocolate. Okay. So I have a plane, and then here's a line on the plane. And then I have another plane. Where do they meet? A point. That's right there. Do you see how it's still a point? Well, this paper doesn't make any sense unless we realize it's 3-dimensional. We don't just have x-axis and y-axis. We also have a z-axis. Wait, does that mean this point could actually be graphed? It does. On a special calculator, or if you can use your imagination for a second. Okay? Now, because the z value is 0, that kind of spoils it. Okay? But let's pretend for just a minute that the z value is 1. Okay? So here's my x-axis. Here's my y-axis. Where's my z-axis? No PDA in class, please. X-axis, y-axis, where's the z-axis? It's coming straight up out of the paper. Okay, so it's hard to draw 3 dimensions in 2 dimensions. So here's what I'm going to do. And I'm going to ask you to use your imagination. Can you tell that that's going out the back of the paper? Okay, so I would go over 8, down 2, and out 1. So I went over 8, down 2, and out 1. You okay with that? It's weird. I know it. Okay, it's not something we normally have to do because, again, it's hard to draw a 3-dimensional graph on 2 dimensions. Because that's where the z-axis is. The z-axis comes straight out of the paper. Like this. Okay, so really it's over 8 out down 2 and out 1. Well, it's like hovering right above the paper, right? Can't really draw that. Mhm. It's already even hard to show you on the video because it's still just 2 dimensions, right? What you're seeing on the video, because what you can't see is that there's space underneath my finger right now. My finger's not touching the paper. Now it's touching the paper, and now it's out from underneath. Okay? You see what I'm saying, though? Do you at least have the concept in your mind? Okay, so you're not going to have to graph this. I'm just trying to get you the concept, okay? But what I need you to know is how to write the answer. Creed said XYZ, right? So we would write 8, -2, 0. And I need you to know what that is called. What's this one? What's this one called? What's that called? It's called a point, but what else is it called? Ordered pair, right? If this is an ordered pair, what is this one? An ordered triple. Okay, it's called an ordered triple. And that's how we write our answer when we're working with 3 dimensions. X, Y, and Z. Cool? Math cool. I get it. It's math cool, but it's kind of cool. Okay? Any questions about this so far? Now, here's the deal, guys. Do you notice, let me zoom out even further so you can see this. Do you notice that it took one entire page to do a problem? So think about how many places there were that I could have messed up. There's a lot, right? There's a lot, so we just have to be careful. That doesn't mean it's hard. I mean, I write big, for goodness sake. Okay? So if I wrote smaller, maybe it would only take half a page. So I don't want you to get overwhelmed by how much work it is, because it's not hard work. There's just multiple steps that you have to take care of. Okay? So let's do another one. Another piece of paper. X plus Y plus Z equals 24. 5x plus 3y plus z equals 56. And x plus y minus z equals 0. We're solving by substitution, so our first step is to isolate a variable. Okay? How many possible variables do we have to choose from, first of all? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 variables to choose from. And could I choose any of the 9? Yes. Are there some that might be easier? Which ones? The ones that are by themselves. Okay, so XYZ, Z, and XYZ? Would this be a good one to choose? Why not? It's because it's negative. Now, it might be in another problem the best one to choose because it might be the only one by itself. Now, you'll still have to divide everything by negative, but in this particular problem, it's probably not the best one to choose because we have 6 positive variables that we could choose from that are by themselves. It does not matter which one we choose. So, would you like to choose one? First x. So if we're choosing the first x, and the reason I chose the first x is because she suggested the first x. Okay? It doesn't really matter. She chose the first x, so we're going to go with the first x. So let's subtract y, and let's subtract z. So x equals 24 minus y minus z. What should I do with it? Plug it in. We're doing substitution. Once we solve for a variable, we want to substitute it. Which one would you like to substitute it in? Probably the bottom one, right? It's a little bit easier. So I'm going to plug it in right here. Okay? So I'm going to rewrite that problem, but instead of writing x, I'm going to write what I know x equals. So I'm going to write 24 minus y minus z, because that's what x equals, and then plus y minus z equals 0. Now, as it turns out, you made a very good choice. Because look what happened. Look what happens. If I combine my two y's, what do I get? It cancels out. That's 0. So I ended up with 24 minus 2z equals 0. How do we solve that? We can do that. That's fine. Move the 24 to the other side. Negative 2z equals negative 24. So z equals what? 12. So now I have one of my variables solved for. But now what? I kind of got to start over, don't I? Because if I plug it in right here, which is a fine idea, I still have two variables, an x and a y. Does that make sense? Okay, so what do you want to do to start over? We could take this x and substitute it into the middle one. Couldn't I? Okay. So 5 times my x, which is 24 minus y minus z, plus 3y plus z equals 56. Is that the only thing I could do? No. Just, it was suggested, so we did it. Okay? The hard part for me about this is I can't just say these are the exact steps, 1, 2, 3, 4, because there's so many different possibilities that we can do. So what I'm trying to make you aware of is that try something. I want you to try something. Now, I don't want you to just willy-nilly guess and do a whole bunch of stuff. I want you to have logical things that you're choosing. But if we're solving it by substitution, we should probably be substituting stuff in, right? Okay? Oh, we could. We sure could do that in just a second. Yeah, absolutely. Okay? But can we go ahead and simplify this first? Is that okay? And then we can go ahead and plug in our 12? Because that sure will help, won't it? Okay? So distribute, distribute, distribute. 5 times 24? What? No. It is. Oh, it is? Yeah. I know that 5 times 25, because I know 5 quarters is $1.25, so I know 5 times 25 is 125, and it's just 1 less 5, so it's 120. Or 5 times 20 is 100, and 5 times 4 is 20, 120. Okay? Minus 5y minus 5z plus 3y plus z equals 56. I've got y's and I've got z's, but I can also subtract 120, right? Mm-hmm. So my y's will be negative 2y. My z's will be negative 4z. And 56 minus 120? $64? Do we need to check it? Or okay, we're good? Okay, so right now if we continue going with this, we're going to get the problem wrong. Because it's negative 64. That's exactly right. Okay? So good job, good job. All right? So now what? What do you want to do? Substitute in my z right here. Put that over there. Negative 2y minus 4 times 12 equals negative 64. So negative 2y minus 48 equals negative 64. So add 48. So negative 2y equals negative 16. Y equals 8. Now what? We could plug it into the x right up here. right? X is already solved for. Let's go up there. 24 minus 8 minus 12. X equals 4. So what's my answer? 4, 8, 12. Is it correct? I want to say so too, but I want to be positive. Let's check it. 4 plus 8 plus 12 is 24. Is that correct?
Yes.
Okay. 5 times 4 is 20. 3 times 8 is 24. Plus 12. 20 plus 24 plus 12 is 56. Okay. 4 plus 8 minus 12 is 0.
Yes.
So is this the correct answer? And are you positive? Yes, you are. Do you have any questions?